was this study that was conducted in Paris where these workers in a copper smelter, they worked in heat and chemicals to extract copper, right? And these were extremely poor working conditions. Usually mortality rates, were extremely high in these places. However, when cholera broke out between 1830 and 1850, all of the 200 employees survived. Like, it was basically they were immune. And then a study was made, and around 400 to 500 other copper workers in the area were also immune. And this was then actually related back to their profession because they were handling so much copper.
Hey everyone, welcome to It's a Material World. We're the show that uncovers why material science will change the world. Consider subscribing and hitting the like button down below. It would really help us out. And also, we have a free MSE Company Database categorized by industry sector, location, as well as internship and full-time titles. So if you're interested in that, you can find the link in the description below. And now, let's get on to the episode.
Hey everyone, we are excited to welcome today's guest, Melina Gerdts, CEO and co-owner of CuConcepts, a biotech company battling the threat of infectious diseases, especially those transmitted via contaminated surfaces. Leveraging her master's in strategy and innovation management and industry experience as a management consultant for industrial fields like plastic processing, she's in charge of making sure CuConcepts is on a track to achieve its goals, which are all circled around innovating the design of surface technology by giving it antimicrobial properties. CuConcepts has developed a highly efficient, nature-based antimicrobial additive that can be integrated into plastic processing, textiles, paints, and coatings, which we're excited to dive into today. Thank you so much for joining us, Melina.
Thank you for having me.
Yeah, so we wanted to start out with kind of the motivation behind these antimicrobial materials and their potential in our future. So the World Health Organization classified antibiotic resistance as a silent pandemic. You actually told us this, so this was kind of news to us, but we were just wondering, so what are the limitations of antibiotics and what consequences could we face as a society if solutions aren't developed to address these limitations?
I'm sure it's not only news to you, Punith. I'm pretty sure most people are not really aware of this issue. So I'll give you like a quick background on antibiotics to kind of explain the answer to your question. So antibiotics they actually came about with the invention of penicillin by this guy called Alexander Fleming in the 1920s in London. And he was sort of described as a bit of a careless lab technician. One day he went on holiday and he returned 2 weeks later and found that mold had developed on an accidentally contaminated petri dish of Staphylococcus culture, so bacteria. And the mold prevented the growth of the staphylococci because basically it produced like a self-defense chemical that can kill bacteria. And that's kind of how antibiotics were born. So they were introduced in the market in the sort of late 1920s, early 1930s. And the first cases of antibiotic resistance actually started piling up in the late 80s, let's say early 90s. Antibiotic resistance happens when germs like bacteria and fungi develop the ability to actually defeat the drugs that are designed to kill them. So that means the germs are not killed and they do continue to grow. This occurs naturally, so processes of mutation, like gene mutation. However, misuse and sort of the overuse of antibiotics in humans, but also in animals, is really accelerating the process. So, for example, you go to hospital because you broke your leg, or maybe you have COVID-19, and it's quite likely that you will be prescribed antibiotics, even though you haven't actually been tested positive for a bacteria infection. It's just like a prophylactic use of antibiotics. So basically, just in case, to prevent that you would get an infection. So this is sort of a huge problem. And with regards to animals, antibiotics are a form of disease control, also for growth because of sort of this hormonal growth aspect, but mainly disease control. Because it allows farmers to, increase the animal count per square meter. So, humans are consuming the milk and the meat and the eggs, which actually is leading to cross-resistance of antibiotics. So basically, antibiotics in animal feed are making human medicine, like are making the bacteria resistant to human medicine. So that's like a huge problem. And with regards to the limitations, right? Sorry. So so overall, the resistance is actually rising to a really dangerously high level across the entire world. So today, it's killing more people than HIV, than malaria. You have, I think, almost, if I'm not mistaken, 3 million antibiotic resistant infections in the US alone every year. And you have a bunch of sort of new resistance mechanisms that are emerging and that are actually like threatening our ability to treat common infectious diseases, because anyone can get it across all age groups. You have growing number of infections of like pneumonia, tuberculosis, gonorrhea, salmonellosis, all these fun diseases nobody wants. And it's actually becoming extremely hard and sometimes impossible now to treat them because the antibiotics are just becoming less effective, And so without urgent action, we are kind of heading for a, let's say, post-antibiotic era in which common infections and minor injuries can once again technically cause deaths. So the World Health Organization actually expects like around 10 million deaths per year related to antimicrobial resistance by the year 2050. So that's really not far away. And so, it's important that we tackle this.
So I think you did a great job illuminating why like overuse of antibiotics is leading to these resistant strains. Is there any figures or anything at all where it kind of gives us a timeline for like the most common penicillin or the most common antibiotics that we use today will no longer be useful by that 2050 mark? Or is it a much tighter timeline and we can just pivot to other antibiotics for right now?
I mean, that is a very difficult question, mainly because it's not that easy to predict. It also depends on where in the world you're doing, let's say, this analysis, because in, let's say, less developed countries, the amount of antibiotics prescribed are different than in Western, let's say, or developed countries. So there is a list called the ESCAPE list with a K, ESCAPE, which is a list actually of the most dangerous bacteria that are growing more and more resistant to antibiotics. But like to give you a proper statistic wouldn't really be that it's not a sure thing, let's say.
Well, in previous episodes, we have alluded to the fact that copper has great antimicrobial properties. And this is kind of where you guys come in. But what mechanism does copper use to attack microbes, and how can it be incorporated into other material systems where antimicrobial properties are needed?
So copper honestly is amazing. It's a very cool metal. Basically, copper oxidizes, right, and releases copper ions. And this basically weakens the bacteria. So these like oxidizing copper atoms like weaken the bacteria because they kind of pull these electrons from the atoms that make up the cell wall. And so it's just kind of like pulling bricks from the wall. Eventually the cell wall breaks, right? And then the general cell is destroyed. So also the DNA and RNA in the cell nucleus, which is extremely important because if that would survive, then it would be able to mutate. So essentially, microbes cannot actually become resistant to copper because of this mechanism. And the fun thing is now, how can you actually apply this to other materials, right? So our technology is copper. It's basically a copper-based additive. So you can imagine this kind of powder that has copper ions in it, right? And this powder can be integrated into manufacturing processes, as you already mentioned previously, like polymer processing, textiles, and paints and coatings. So imagine you want to make, a phone case antimicrobial, for example. Sorry, let's say you want to use TPU or PC or something. And we would basically make a master batch, right, or compound. I'm not sure if I should explain this, but basically it's just the plastic granules that are put into the processing machines that are then heated up, melted, and then, for example, injected into a a mold, an injection molding. And this contains our additive, right? So it can be processed at up to, let's say 200 to 250 degrees. And so the final product, this phone case, will actually be antimicrobial. So, next time you wash your hands and then you reach for your phone will actually be clean instead of, touching a dirty phone again. So just as a use case example.
Interesting. So what would you say is like the most common surfaces? Is it that phone case where like these bacteria could be transferred, or public transportation, or something else?
To be honest with you, I used the phone case as an example because it was our very first product, the Q case. And so, yeah, it's an easy example. But I mean, phone cases or your phones in general are, I think, 17 times dirtier than a public toilet seat on average. That's like a fun little statistic. Yeah, and you'd think, since it's your personal device, like nobody else is touching it. However, you are touching so many things during the day, and then you retouch your mobile device, and then you touch your face, and so this actually is a very big source, let's say, of potential infections. But at the end of the day, it is more public areas, like public transport, airports, just sort of even hospitals, areas where you just have a lot of people touching door handles, touching elevator buttons, that kind of thing. Because actually 80% of infections are transmitted via touch. So this is like a statistic from the World Health Organization. And I mean, even if you have something like, I guess, COVID-19, which is said to spread mainly through aerosols, even those at some point, they fly through the air, right? And they maybe land on some, like on a door handle or something. So if you touch that, then that is how you would contract an infection, definitely.
Wow. It's just making me like more cognizant of like everything that I've been doing over the past weekend. So good to keep in mind. Obviously, we'll make sure to continue to wash my hands, but also I think we should definitely focus on like the material solutions that could play a role here. And so oftentimes, just in general, new solutions to existing problems take inspiration from our past. And in a previous call, you talked about kind of the history of humans treating infections. So can you walk us through that and how that history has inspired CuConcepts to develop innovative new solutions?
Yeah, that's a great question. Also great story. So thank you for that, Punith. I mean, we talked about treating infections with antibiotics today, but if you think about it, what were people doing before that? What was happening before the invention of penicillin, And the focus actually lay on preventing infections in the first place. So not only treating them, but actually preventing them. And this dates back all the way to the ancient Egyptians, sort of like 2600 BC, where they were using copper containers to store water and sterilize it in this way, as well as use these kind of copper infused solutions to sterilize chest wounds. Then you have stories in the Middle Ages where people would gargle copper solutions against like sore throat and stuff. And then super exciting as well in the 1850s, when you had cholera, there was this study that was conducted in Paris where these workers in a copper smelter, they worked in heat and chemicals to extract copper, right? And these were extremely poor working conditions. Usually mortality rates, were extremely high in these places. However, when cholera broke out between 1830 and 1850, all of the 200 employees survived. Like it was basically, they were immune. And then a study was made, and around 400 to 500 other copper workers in the area were also immune. And this was then actually related back to their profession because they were handling so much copper. So in the 1920s, then, with the invention of antibiotics, the treatment of infections became extremely cheap. so it's so much cheaper than focusing on the overall prevention in that case. And also other materials, like plastics, aluminum, stainless steel, they kind of took over and substituted, copper beds, doorknobs in hospitals and stuff, because actually copper was used mainly before that. And so with this antibiotic resistance on the rise, honestly, a shift is necessary, back to the prevention of infections. I think the COVID-19 pandemic actually gave a huge push towards this, because suddenly we were being reminded to wash our hands, even though we were adults, right? We weren't kids anymore, but it was like adults were telling adults to please wash their hands to prevent, acquiring infection in the first place. And CuConcepts is part of this shift. We believe it's crucial, to equip surfaces with antimicrobial properties, because it really does significantly reduce the risk of infections. And basically, preventing them in the first place. So it's kind of like part of environmental disease control. You could see it that way. It's not the holy grail of solutions where if you say, okay, we've covered our surfaces, like we're completely safe from anything, like that's obviously not how it works, but you can significantly reduce risks around this. So it's an important part of any hygiene concept.
So one quick question about copper in general. So like you've said, copper's had this storied past, but the mechanism that you described is that it's oxidizing. So is there a lifetime for a copper vase, for example, or does it find an equilibrium? And I'm sure with enough copper, it would take years or maybe even hundreds of years to outlive its usefulness. But maybe going back to your product, is there a lifetime for a textile or a ceramic use, or is it just so much copper that it doesn't ever really get to that endpoint?
Also a really good question. Actually, the lifetime is as long as the material lasts. So if it is within a phone case or within, if it's a polymer fiber within textiles, then it's as long as, let's say, we recycled the piece of plastic or the textile. That's the moment where the material would lose its antimicrobial property, right? But if you don't recycle something, let's say, and I don't know, let's say this plastic part lasts 200 years, then technically the antimicrobial effect will last the same.
So the copper isn't the constraint there.
It's not, it's this continuous sanitization essentially without really, an end date.
Interesting.
Awesome.
And are there any other materials, like you've really focused on copper, so I was just wondering if there's any other materials that have these antimicrobial properties?
Yeah, definitely. Also a good question. So this is, let's say, in the domain of our competitors, you will find a lot of nano silver based technology. So silver is antimicrobial. It is less efficient against viruses. So it is mainly used against bacterial and fungal infections. Something to keep in mind here is that silver works with moisture. So if there is a dry environment, then the silver is not antimicrobial. That's super important. So it really is a great solution for a lot of applications, if those are in water, for example, but for a lot of other things, not really. Then there's titanium oxide, which is also used sometimes. However, it is only photoactive, right? So you would only have the antimicrobial effect during, I guess, daylight, and copper also works at night. And then there's zinc. Zinc is also being used. Zinc has mainly antibacterial effects. But since it's a material that is, found, let's say, in the body, and it's also in a way healthy to some extent, of course, that is also used in medical applications.
Awesome. Well, you mentioned in a previous answer that antibiotic issues with humans can come from even the food that we consume. How can antimicrobial materials improve the safety and longevity of that food?
Yeah, so the food chain is a super important application field for antimicrobials. And here, especially looking at let's say the processing and packaging of food. So when you look at food processing, you have a lot of machinery, a lot of processing surfaces involved that have to be continuously sanitized, right, after coming into contact with food. You know, we have a lot of like costs for disinfection, usually involving a lot of chemicals and a lot of time, you know, being spent cleaning processing equipment, so a lot of downtime of machinery. Like the global food and beverage disinfection market is also a multi-billion-dollar industry, believe it or not. So the food basically gets infected before it gets packaged. Sorry, disinfected. My bad. They use like UV ray technology for that. That's quite common. But yeah, so I mean, imagine if you would apply coatings, you know, to the surfaces or to the machinery in these factories, making or even making the plastics, you know, machinery parts antimicrobial from the start. You could reduce a lot of costs and risk, right, of infection, because unfortunately food processing plants, even though they are heavily, you know, regulated, they are not always fully hygienic. Do you guys know Ferrero, the company?
No.
Ones that make Nutella?
Oh, okay. I know Nutella.
I'm allergic to nuts, so
Okay,
not quite as
fair
familiar.
enough, fair point. But yeah, Ferrero actually, they like just last month, police shut down a plant of theirs in Belgium because the factory was contaminated with salmonella. And, you know, this was right before Easter too. So they had, you know, this whole batch of chocolate for Easter, and all of this had to be, you know, canceled. And I mean, yeah, the risk of these scenarios really can be significantly reduced, you know, if you would have surfaces acting like antimicrobial surfaces that act as additional environmental control, basically. Yeah. And then if you take a look at food packaging, right, which I mean, it is synonymous to food safety, right? I mean, the packaging is supposed to make sure a product arrives safely at the consumer, you know, in the intended shape and quality. So that's the role of packaging. But of course, it doesn't ensure that a tomato, you know, or a chicken wing won't be contaminated with some sort of like foodborne disease, you know, like a fungus or salmonella by the time it arrives. So antimicrobial materials and packaging can actually extend shelf life of a product, and of course reduce the risk that infections, or let's say that bacteria colonies are actually formed, you know, that the environment is not friendly towards, let's say, a bacteria colony. So, you know, again, you can imagine when you make this, let's say, plastic film, you know, for the wrapping, again, here you could just include the additive, and then the packaging would end up being antimicrobial. Can you guys think of an idea where this would not be a good idea? Like with regards to food?
Kombucha.
Yeah, good one. Very, very good. I mean, yeah, kombucha or yogurt even, because essentially you have like probiotics, right? So active bacteria colonies. And if you would then have an antimicrobial packaging, like your kombucha wouldn't taste very good. So I guess that is a limitation, right, with applications as well. But yeah, anyway, apart from that, you know, ideally you'll have less food going bad, less food being thrown away, less chemical ingredients in food, you know, also aimed at food conservation. I think in the States, I checked, there's like around 1 million people that get salmonella per year. Around like 6.5 million get the norovirus, which is basically diarrhea. Like if you've eaten some greens that you haven't washed properly, or fresh fruits or something. And yeah, anyway, so in a nutshell, antimicrobial materials can, you know, really increase food safety and longevity along the chain, whilst reducing overall costs, but also packaging, right, for disinfection and stuff.
Yeah, I have to admit, I was just at the store yesterday and just saw a bunch of kombucha, so that's why I was at the top of my head.
Lucky.
That was like such a quick answer, David. I was like, all right.
No, I was impressed. I was like, okay.
Yeah, so I must have known that this was what we're going to talk about today, so it's on the top of my mind. So one question about the cleaning. So your value add of having passive cleaning is insane, and basically it can just continue to produce without ever stopping. What is the time difference? So if I put like X amount of bacteria on a surface and I do active cleaning, where we take a second and disinfect and wipe it down and use UV rays or whatever they would use, versus copper, is the time for it to clean like 99% or some threshold roughly the same, or for the passive cleaning, is it going to be a little longer? And if that is, what are some of the levers that we can pull to help your passive cleaning work faster?
So we actually did a kind of case in a town hall in Germany where we identified high touch surfaces. So mainly door handles, handrails, elevator buttons. And we chose a certain percentage of those that we then covered with this protective adhesive film that we have, it's kind of transparent and you can just stick it onto surfaces, but it contains the additive. And, we kind of, so we installed that in some places, and others we said, just keep on cleaning like you usually would. And then after, I think 3 months, and then we told them also, do not touch ours, like do not touch the ones covered by CuConcepts, like by the film. And we came back 3 months later, and we do these tests with ATP meters, like I don't know if you know what that is, but it's basically just measures like the microorganism activity on a surface by measuring the ATP. And it turned out that our surfaces, even though they had not been cleaned once, were cleaner than the surfaces that were being cleaned every day by normal cleaning detergents and stuff. And at the end of the day, copper continuously sanitizes, while if you clean it in the morning or in the evening, a surface, then it is only as clean until the next person comes by essentially and touches that surface, right? And so if you would then have to manually clean that, technically you'd have to, run behind every single person touching a doorknob. But if you would have the antimicrobial material, you'd at least be sure that the microbes would all be deactivated on the surface. Important though is also that you can't just leave it, for like years without ever once cleaning it with like a cloth or water, because there would be the risk that biofilm would form. So basically just a bunch of microbes on one spot. And even though they're dead, if they start creating this layer, that would potentially reduce the efficiency of the copper ions basically doing their thing.
Okay, so in addition to like public transportation or elevator buttons, just public areas, antimicrobial materials can also make an impact in the medical industry. So can you talk us through what advantages like antimicrobial materials provide in this industry and maybe some interesting applications?
Sure. I'm gonna start with a counter question though. So
okay.
do you guys know what nosocomial infections are?
No idea.
No.
Okay. It's basically a fancy word for saying healthcare associated infection.
Oh, okay.
Mm-hmm. So basically, that's just an infection that you would get when you go to hospital or some kind of healthcare facility. And so in the States, it's 1 in 31 hospital patients actually per day that have at least one healthcare associated infection. And this costs like on average, like 40 to 50K more per patient.
Wow.
And I mean, I think
no wonder our insurance is so high.
Well, yeah. And I mean, I think the average is around 100K of deaths per year just for this. And, depending on your general health state, of course, you're more likely to contract one or not. But yeah, let's say if you get infected with a bacteria from the escape list, you're going to have a problem. So that's not great. So protecting surfaces in medical institutions, right, like hospitals, but also like nursing homes is super important. Of course, there's surfaces that come to mind that we basically just spoke about, like the buttons and the door handles and stuff, maybe even iPads, like some hospitals use that now with patients. But there are also like a lot of medical devices that need protection. So for example, you can think of surgical equipment that like I'm not sure how to, like the small braces that you can clip onto your fingers for stabilization, things like this. These are actually often 3D printed, which is also quite interesting. Just a side note, like, because we actually have antimicrobial 3D printing filaments. So this is like one of those applications where you can just make something real quick, that will have that effect. But also like personal protection equipment, like gloves or masks or surgical kits, like the way you wear. If you would have textile, antimicrobial, then this would reduce the risk of just transmitting infectious diseases that are airborne in the hospital, for example. Another interesting application is actually looking at how patients acquire the nosocomial infections. So like the most common ones are urinary tract infections. Then you have like respiratory pneumonia and just like in general surgical site infections. So when you've had surgery, like that area will usually heal much slower. And the urinary tract infections are actually often caused by urinary catheters. So that's almost like 75% of them are caused by that, because basically they sometimes allow bacteria to enter the body. And you could essentially make these antimicrobial. It's pretty simple because it's just extrusion of a pipe, right? Just a very small one. So you take a look, I think there's like latex and silicone being used for these applications, even though Punith, I think you know more about that from the last course. Another application would be implants. So for example, hip or knee implants. You have like the most common infection is called coagulose negative staphylococcus. It's a bit complicated, but basically it's just an infection like within the wound of where the implant is connected to your joints. And this is usually like a huge pain for patients, but also it just costs a lot of extra money, So if you could reduce that risk by adding, for example, like an antimicrobial coating on that implant, you could really increase the added value for patients as well, And then there's one other sort of fun future market, which is dental, especially 3D printing of dental implants. But it really depends on how the copper ions react in the mouth, because the thing is, our mouth has actually a bunch of really good bacteria, right? That help you preparing food, for your digestion, for example, and you don't really want to kill those. So this is actually another little limitation with regards to applications, because the moment you have good bacteria that you definitely don't want to destroy, then yeah, the options are thin at the moment. So, but yeah, that's the medical field for you. Just an example, so.
Yeah, I appreciate that. I think like the medical device industry is fascinating. So, and especially you mentioning like the catheter side of things, that's very interesting. So one quick question, I guess, is more related to like the sustainability side. So I think very early on in this episode, you mentioned like recyclability of materials in general. So I was just wondering how can that be facilitated with like CuConcept, like what is your company doing to like address these challenges and continue to like improve from the sustainability standpoint?
Yeah, so sustainability is actually an extremely important topic in our field. It's also a way that we differentiate ourselves from most of our competition. So as I mentioned before, right, some of the other antimicrobials are nanosilver, zinc, titanium oxide. Yeah, so nanosilver in particular, is really bad for the environment if it goes into the groundwater, especially owed to the nanoparticle size. Because it could also get into parts of our body that we don't really want, right? So overall, this is not something we want to be putting everywhere. And we actually use only recycled copper as a basis for additives. So copper that is 3 to 4 times recycled already. We don't use any, toxic chemicals in the process. And the finished materials containing our additive can be recycled without a problem. So what we talked about earlier, except for the fact that afterwards they will have lost their antimicrobial effect. So yeah, and in order to actually increase, let's say, the sustainability pillar within our our company, we're also working currently on plant-based additives that have antimicrobial effects. So yeah, I can't unfortunately get too much into that right now, even though it's extremely exciting. But yeah, I mean, that's the way we're trying to kind of battle this topic as well from the other side. Yeah.
Yeah. So one question I had on the sustainability is that, like we said before, is that the antimicrobial effects will last as long as plastic will last, or whatever the substrate is. Because we know that, at least in the US, the recycling is not the best thing ever. A lot of times plastic will just lay on the side of the road, etc. Will basically creating a safer place for the plastic to be by not allowing like microbes or anything to help break it down. Will that lengthen plastic's life at all? Like, will that be an unintended side effect from our not adequate recycling system? Or will it not affect the lifespan as much as it might possibly?
That is, yeah, that's a good question. Because as you said, like it is at the end of the day, bacteria that sort of digest the plastic and break it down, right? To be very honest with you, this is not an issue that we've seen so far. So, I mean, we also work with PLA, for example, which is like a biodegradable material, right? And even here, it doesn't it doesn't seem to kind of mess with that process. But to be very honest with you also, since this is a long-term it's a long-term question, right? And from the use cases we have had thus far, this has not been an issue, but it is something that we are also looking into, like in general, just the life cycle, you know, of the materials that we use as well. Yeah.
Well, that's good that it doesn't stop it from degrading.
Yeah, that would be difficult.
Cool. Well, we discussed a myriad of topics today revolving around antimicrobial material solutions and why they are so vital to society. For any MSCs who would like to pursue a career in this industry or end up in a CEO role like you, what advice would you give them based on your experiences and what you've learned along the way?
I think on one hand, it depends on if you want to go only into research, so kind of remain in the technical side of things, or if you would also want to combine this with entrepreneurship, right? So either founding something yourself or actually being on the business side, sort of the innovation management of a company that is doing something like this. If you want to be more in the let's say scientist role, right, a bit more in the research world, I guess it's important to understand if you're a specialist or if you're a generalist. Like I think people generally know if there's one thing that they're super passionate about, that's probably what they will do. And then others are like, I kind of like a lot of things and I'm good at a lot of them and I don't know what to choose. That is also a strength, right? Because we need specialists in our team, for example. You know, we have the biochemists, we have the mechanical engineers, the chemical engineers. But then what is important is to have people that are also aware of like what's going on outside of their bubble, right? Because that is actually how innovation usually happens. It's when you combine things from different disciplines, right? And you create something new. And so I guess it would be kind of my advice to actually just keep an open mind, like even if you're a specialist, but also if you're a generalist, sort of focusing on things here and there, it is actually a strength. So yeah, I think keeping an open mind and trying to also dive into other technology trends, you know, just out of interest, that will increase not only like your horizon, but your ability to connect dots that haven't been connected yet, right? And that is super important in technology driven firms, right? Because innovation is everything. It is your competitive advantage. And yeah, I guess if you would rather end up on the, you know, on the business side of things, so either actually founding something yourself or becoming a CEO or CTO, well, CTO is probably still very technical, but let's say the overall strategy of a STEM company, I do advise you to definitely have some portion of your studies focused on business, just to understand the basics, right? You don't have to become an expert at corporate finance, but you know, you kind of do have to understand how it works overall. And then it would also be good if you then combine this with, you know, something more technical. So for example, microbiology or something, because then you will not only be able to speak on a higher level, right, on a strategic level, but you can also kind of deep dive into the topics that, you know, require some specialist knowledge. And that will make you a much better leader because you will be able to also relate to the technical department, because communication is always crucial in these situations. So yeah, and also want to encourage more women in like STEM fields in general, or tech in general. But because, you know, at the end of the day, if you just if you have a good education and you believe in what you're doing, then you'll be fine, you know. So I think that's something super important for all the ladies out there to remember.
Absolutely. Yeah, thank you so much, Melina, for joining us today. I think that was wonderful advice to wrap our episode on, and we really appreciate you joining us. I learned a lot about copper and antimicrobial material solutions.
Thank you guys for having me. It was a blast, and I look forward to your other episodes.
Nice. As a materials engineer, we can make an impact in nearly every single industry. But with that versatility comes a lot of different options to choose from. So if you have no idea which industry or position is right for you, believe me, you're not alone. I've been there, done that. But just for a moment, imagine narrowing down your ideal role and company by the end of this week. Imagine being able to secure your dream job offer without having to apply to hundreds of job openings. Our online course, MSE Academy, includes video testimonials, resumes, interview prep, and mentorship from materials engineers who have been in your shoes. We also connect our members with companies and industry professionals in our expansive network to help accelerate your job search as much as possible. To learn more and get started, simply click the link in the description below. And if you enroll within the next 24 hours, we'll add 3 bonus career development resources. I hope to see you there.